Hi, this is Jim Metcalf, and we're at the 2019 Geological Society of America annual meeting. And at this meeting, a few of us who have been involved with this project have been presenting some of our results. I am primarily working on the uranium, thorium, helium dating of rocks from the Ruby Mountains region. And so myself and two of the students working with me, Carlton Mueller and Nicole Gonzalez, all had posters presenting some of our most recent zircon, titanite, and apatite uranium, thorium, helium dates. Of course, these are systems that allow us to understand the cooling history of the rocks, specifically as they cool through maybe 180 to 70 degrees Celsius. So as they kind of moved through the upper crust and got to the surface. And so we're still collecting data, but some of our results, I think, are starting to kind of crystallize and refine themselves, and we're starting to understand them a little bit better. And I think what we're documenting, which makes a lot of sense with what Al McGrew has been documenting with the argon data, is that we're actually seeing multiple episodes of exhumation and cooling. So that means that as the rocks were moving up to the surface, it didn't just happen at once. It actually went through a couple different stages. And what's really exciting is that one of those stages is a little bit earlier than we'd previously thought. So that's what we've been referring to as an Eocene cooling event. So that's cooling that happened, an exhumation that happened about maybe 40 million years ago, 35 to 40 million years ago. We're seeing that in some of our zircon helium data from both the southeastern part of the East Humboldt range, as well as in the Wood Hills. We also have an extensive data set now through the rest of the East Humboldt range and the Ruby Mountains, going all the way down to Harrison Pass, where we've seen that the next phase of cooling and exhumation probably started maybe 25 to 20 million years ago, and then went all the way to about 12 million years ago. What's really exciting for me, though, in addition to seeing those different periods of cooling, is seeing how much variability there is throughout the whole mountain range in the timing. So that there's these patterns where it's a little bit older, maybe down in the south, it's a little bit younger, maybe in Lamoille Canyon, and then up near Soldier Creek, it gets a little bit older again, and then into Secret Pass, it gets younger. So I think in addition to just the fact that we're identifying these multiple phases of cooling, the really exciting part is that we're also starting to really, because our sampling strategy is very dense, and we thought about where we wanted to sample before we went out there, and planned it very well, I think that we're also starting to document a lot of spatial and temporal patterns. So how cooling and exhumation happened both throughout space, so where in the range it happened in really interesting ways, and then also in time. So it might be a little bit older down in Harrison Pass, it might be a little bit younger up in Lamoille Canyon, it might be then a little bit older up in Soldier Creek, and then it might be even a little bit younger in Secret Pass. And so what we're seeing is that you can't actually take data from one part of the range and extrapolate it everywhere. It was actually a very complex way that these rocks came to the surface. Al McGrew and I have now been starting to think about what that means for fault dynamics, how the faults were arranged, how they were dipping, how steep they were, where in the crust these faults were active. It's one of the great things about these patterns of exhumation and cooling is that they really do require a variety of physical processes to be active. And so that's what we're hoping to do now. The next step that we're working on, Nicole Gonzalez, who's been working in the Wood Hills, Carlton Mueller, who finished an honors thesis in the Soldier-Cranka Creek transect, we're starting to put their data, their very nice data sets, into some thermal modeling packages, so we can actually really try to nail down the complex interplay between helium production from radioactive decay, helium loss due to diffusion, and then the changing characteristics of the grains because of the accumulation of radiation damage. All these things are happening over millions and millions of years, and these thermal modeling packages are really going to help us kind of refine our view of what the possible histories would be. So we're starting to put together those models, which are then going to integrate with a lot of the argon-argon data that Al McGrew has been producing. And what we're going to be hopefully producing soon is a very complex picture of one of the most fascinating geological regions in the country.